It is 4 p.m. our time. Hello and welcome to the webinar, How to Become an SLS Open Parameters Pro. It's a great occasion for us again to meet with you. We see there are a lot of attendees. It's a very special webinar, I have to say, because we're gonna go much more into details today, especially in the second part of this meeting. But before we move on to the main topic, of course, I'm sure you will have a lot of questions, or you would like to get like a deeper dive into this topic. If you have questions and you would like us to answer them, you can type those questions by using the questions button, or you can use a chat and write your question with a question mark at the end. This way we will be able to grab these at the very end, display them on the screen, and we will be answering them for you. My name is Dominik Stasiak. I'm channel manager here in Sinterit, responsible for DACH and for some other regions. And together with me is our application engineer, Mr. Jakub Malec. Jakub is specializing in the Sinterit Studio and in all the settings, so he's the best person to have for this meeting today. The meeting is moderated by our colleague Anna. Anna is in the background. She's taking care about all the webinar going on properly. So for today's meeting, we would like to tell you a few words about Sinterit, starting with what is SLS, what is Sinterit, what's behind the company, who we are actually, and then we will move to open parameters. So we will start with brief introduction, then we will go through the Sinterit Studio, which is the platform for arranging all the parameters. We will tell you about why we are giving the access for the open parameters. We'll show you how you can change the print settings. Of course, we will use examples for that. And the last topic of today's webinar is the pack density optimization. So a way to save time and money by using the slicer, the Sinterit Studio, in the most optimal way. So a few words about Sinterit for those who don't know us yet. Sinterit was appeared in the market actually 8 years ago, was set by two ex-Google engineers. And from that time, within those 8 years, we grew up a little bit. We are around 100 people right now. Sinterit is located in Kraków. Kraków is in Poland, so we are a fully Polish company with a complete facility here in Kraków. So all the production, R&D, all the departments, everything is in one place in a very modern facility. And we keep growing. Actually, we need more room right now. Everything is going like we planned. So few words about SLS, just to give you a better understanding, because SLS, like open parameters, are a function of SLS. They are not possible in all 3D printing technologies in the same way, especially because of the construction of the printer and because of the specification of the technology. There are different modifications or variations of SLS technology. Actually, you might find printers which have open construction, you might find printers which have very closed construction, and you don't have actually full access to the bed. Sometimes you find only print bed, so only one chamber in which the model is being created. Sometimes you have two beds, print bed and feed bed. So our version of the technology is using two beds, feed bed and print bed. In the beginning of the process, when you are starting the process, what you need to do is simply load the feed bed with powder, and then during the printing process, recoater is moving the thin layers of powder into the other area, into print bed, which is going down layer by layer. And once the layers are there, the new layers, they are heated up to a certain very, very precise temperature. And laser is doing all the missing part of the work. So it's giving this last quantum of energy needed for the powder to change into a solid structure. SLS technology is, I think, the most famous feature is lack of supports. You don't need any supports when you are creating objects. This translates into very important feature that when you are thinking about placing your models in the build chamber, you need to think about it in 3 dimensions, like fully in 3 dimensions. So you don't use only print bed, but you are using a full print volume, which means because there are no supports, you can load objects one over another, and they will be hanging, so to say, or floating in the powder without the necessity of being supported in any way. Which means if you have lots of iterations of model that you want to print in one job, or you want to use your printer for a small-scale production, SLS is the answer for that. The other very important feature of SLS is the possibility of printing very complex internal geometries, like on this model. So this is an example that you can see in the picture. This is one of the Sinterit samples, actually. You will be able to find it during Formnext in 2 weeks. We will be there. Very complex internal structures and internal geometries, again, thanks to the lack of supports. Of course, when you print such model, you have it hidden in a brick of powder, so to say, and then in the post-processing, you get rid of the extensive powder, and what you are left with is a very detailed and complex model. The other feature is a great dimensional accuracy of SLS printouts. The accuracy comes from one of the very, very important aspects of SLS here, which translates into accuracy, is the isotropy of the elements, which means elements have very, very similar mechanical properties in all dimensions. Doesn't matter how you place them, you can be sure that the places where the layers are will not be creating very, very big difference in when it comes to the strength to the parts which are like supported layer by layer. And moving parts, SLS, when you first meet SLS, for example, when you go to trade shows and you start seeing different technologies, and you grew up on FDM printers or SLA printers, and first you see a printout like this one, which is a single element, single printout actually, having springs inside, having movable elements, I guess you will be surprised. This is something very typical for SLS or for powder technologies. You can print complex mechanisms, like composed of moving parts, because of the lack of supports again. So anywhere where you need to have some more complex elements, SLS will be the right answer. I mentioned already about isotropy, but combined with very high possibility of printing high level of details, you can get elements which will be fitting each other perfectly. This is also typical for SLS. Again, thinking about the process and about the printer, you think about the different applications, brings you to questioning about the materials. This is a main question actually when you are thinking about your printer or about your setup in a long term, in a long run. So not only about the current projects that are running, but also if you are considering projects that may appear in the future, and these applications there might require different properties of the printouts. For example, elastic ones. This is a key question to ask when you are choosing a system, if the system has this possibility of printing with elastic materials. Not all SLS systems have this possibility, even though most of the manufacturers have elastic materials in the offer. But the question is also not only if there are elastic materials in the offer, but how easy it is to change the materials after one printing process, to change the materials for another print job where totally different materials will be needed. This is very important questions also when you are thinking about the optimization of your work. In case of Sinterit, changing the material for elastic one takes around 30 minutes. And this is just one of the examples what you can get. This is Flexa Bright, one of our materials. It shows very nicely a couple of features. First of all, very high complexity of the printout. Second of all, it's elastic. Third of all, it's bright, which means you can dye this model and get different colors, like you can see also here in the picture. Again, depending on the applications and on the projects that you are working on. So just to sum up the advantages of SLS, first of all, is the possibility of high productivity because of the build volume, not build plate. You can load many different models at once. Second of all, it's ease of use, short training, sometimes even no training. If someone has already some experience in the technology, is very, very helpful here. You don't require it actually because it's very easy, and the printers, Sinterit machines are ready to use, ready to go. So we are taking care about the calibration, about setting everything together. Your role is simply to start using it for your projects. Great dimensional accuracy and mechanical properties. These all come, again, depending on the application. You can choose between different powders, between, for example, PA11 carbon fiber material, which is super resistant, super mechanically resistant, or you can use elastic materials, or you can go for example, P11 ESD for electrostatic discharge, if you need to print some very, very specific works having something to do with electronics. Final product can be composed of many elements printed at once, which also saves you time on assembly, and also for many cases when you simply need to present a model to your client or to someone who you are working with, it also saves a lot of work because you don't need to make any assemblies, make any special post-processing for that. And post-processing in itself is also very easy. I don't know, maybe you can see in the back, I have the full system with me. There is a printer with a powder handling station and also the sandblaster. And this is a complete system. This is everything that you need to go and work with the SLS, with the Sinterit SLS solution. So, brief introduction to open parameters, the main topic of today. What are the open parameters? To understand the importance of open parameters and the role that they can play, I always like to start with two things. First of all, comparing closed system to open system. So if you are thinking about closed system in terms of parameters being set by default by the manufacturer, where you cannot modify anything, you just get a you get a profile for printing with one particular powder, for example. This is super convenient. This makes the work much easier because you don't need to think about anything. You just make little or no adjustments. You just load your model into the software and then it gets printed. It is possible with Sinterit. Sinterit has this possibility because we are offering 9 materials at the moment, and each of the materials has fully prepared profile for each of them. But sometimes, on the other hand, you meet projects where you either want to use not one of our 9 materials, but some 10th or 11th material from outside of Sinterit, a third-party material. And you want to modify the parameters a little bit by yourself. Modify the temperature, modify the laser power, for example, modify the laser movement, because you know that it might be needed to sinter it in a bit different way because of the characteristics of the powder. Then open parameters are the answer that you need. How it works, what is key in the printer, and why we have possibility of using those. First of all, heating of the build of the object and all of the cake inside, so everything that is being created, heating up is very, very complex. You might think it's only about the laser and some halogens on the top, on the cover, but it's not. Printer actually has 4 heating zones with a total of 32 heating elements hidden in the walls, so in the cylinder, in the piston, so in the bottom, which is going up and down. Also different heat sources on the top, next to the laser, and of course the laser itself, which is like the final point of heat, of energy to get your model done. So if you want to use different powders, different materials, or get different results, you need to control all those parameters, all those heat sources differently. But open parameters are not only about heating, are not only about heat sources. It is also about warm-up and cool-down time. This also has very huge importance to the final results. Printing temperatures, I mentioned already. Shell, so how thick should be the wall if you don't want to print 100% infill. Laser movement and geometry, this is also very important element of influencing the process. Scale, I guess all of us know it. Sinterit Studio is also offering that. Sometimes you don't want to make adjustments in the model. You know that, okay, we have to make it slightly smaller or slightly bigger to fit some other element that we have already. Then you can use it simply in the Sinterit Studio. Your profiles that you are creating with open parameters can be saved into personal profiles, which means it's stored. It's not being forgotten. So you can adjust all the parameters to your material and then simply use it as one additional profile. Laser power is one of the key elements here as well, and the skeletons, which Jakub will explain in his part of the presentation. So all of these elements are being controlled in the platform, which is called Sinterit Studio. Sinterit Studio is our software and slicer designed and created by us here in Sinterit, specifically for the SLS machines from our line. So we have access to all of the parameters, and we are actually adjusting the new profiles using it. And Sinterit Studio with open parameters version, Sinterit Studio Advanced, is giving you the possibility of using those parameters as well. Jakub will explain a bit more on that. He's the best person to present it more in details. So I give the floor to Jakub.
Thanks, Dominik. Hello, everyone. Like Dominik said, Sinterit Studio is the, let's call it a hub for all the devices you have, Sinterit devices, and also is a main tool you're working with when preparing a build and print for your printer. Basically, the process of preparing the the file, as code file for the printer, is divided into 4 steps. Step 1 is selecting the printer model and the material you're going to use. Step 2 is loading the models and arranging them. In step 3, you slide the models and you can then preview how each layer would look in step 4. When we are talking about open parameters, the most important parts or steps in this regard are step 1 and step 2. Step 1 is where we select, for example, our material. Here is where we can adjust all the settings, all the open parameters globally, or where we can develop our own material. We give access to all 33 of the open parameters we use for the developing our materials. So you can basically use the machine for powder development or use third-party materials like we do. Step 2 is where we go into more model-oriented approach. So when we are going to adjust some open parameters per model, that's where we make these alterations. Okay, but maybe a quite important question: why do we give the access to open parameters to our customers in the first place? Let's start with addressing your needs, basically. Like Dominik said, we have the possibility to go the convenient route of just loading the profile and inserting the models into build volume and printing them. But sometimes the parameters or the settings we find optimal are not perfect for you. For example, you might need the models to be a bit more porous, or you would like the models to be a bit less resistance, because they need to fail at a very specific point. This is all possible thanks to open parameters. The second part is, of course, the material development and use of third-party materials we mentioned before. This is a very important part of the system. We'd like the system to be open, to be accessible, even if we don't have the material you need at the moment. You can use the open parameters to develop your own profile, or you can also develop a material of your own. Next, we have the research. This is an area where a lot of control over the process is needed. So when researchers usually need a lot of control over the entire process of the printing, and we give them access to that, so you can fine-tune every detail of the printing you need. And the fourth part is the sandbox, basically, education. This is where people come out with sometimes quite crazy ideas, and they can play around with all the settings. They can test different materials beyond what we can think about. They can test various effects of the printings and so on. Okay, now let's learn what is the impact, how to change the printing settings. So what are the properties of the open parameters? What are the properties we can change, we can affect? Let's start with mechanical strength. For example, this is one of the nice example of open parameters. You can affect the strength of the models, but by adjusting the power of the laser or the pattern, scanning pattern of the laser. By increasing the density of the scanning, you can make the models tougher. but in the consequence, you increase the printing time, and because of the longer exposure to high temperature, the powder degrades a bit more. You can also go the other way, so you can decrease the distance between scan lines, or decrease the laser powder and decrease the the time of the printing, and also decrease the strength of the models. You can basically adjust these settings to what you need. Second is geometry. This is true basically for every technology, that there are some settings of the models that are more favorable than others. So, for example, every technology has the set of rules, following of which will give you the best results. But sometimes models are very complex and very hard to print. It might happen that one part of the model needs a completely different orientation to be perfect than other. You can adjust for that and compensate by changing the profile of the temperature to get this perfect results that wouldn't be normally possible. Next, we have surface finish. Basically, as I mentioned, we can influence the scanning pattern of the laser. We can, for example, trace the perimeter of each slice, of each cross-section, number of times. We can multiply the number of perimeter scans. That will give us smoother surface, but as well it will increase the printing time. You can also change the distance between infill, so the surface of the scanning area, and the perimeter that traces around the models, to get different quality finish. Next, we have rapid alterations. This is a very important part for engineers and for development of parts, because in one run we can basically print a very high number of various versions of the same model, which decreases the time of developing our models. So we can, as I said before, we can adjust basically every aspect of the laser movement, geometry, and power per model. We cannot adjust the temperature per model, because this is a global setting, so we need to set it for the entire build volume. But regarding the laser power, we can adjust it per model. And the last part is, of course, scale. Like Dominik said, sometimes you need some alterations to the scale, and you don't want to prepare a model for every one of it. You can just adjust the scale for every model and print them in one run. Also, in some rare occasions, you can achieve the best quality of the dimensional accuracy thanks to this adjustment. And now to a couple of settings, a couple of examples for this settings. We want to focus on two of them. Let's start with the shell. We mentioned shell before, but this is a very nice, and I think a bit overlooked setting. We can print the models with shell, so making only the surface and the set depth of the model sintered, or we can print it completely, so sinter the entire volume of the model. What are the differences? Let's start with the shell. I have a model here. I don't know if it's visible, but the inside of the model is still a powder. So you can remove it if you want, but the corner of the model has been ground off to show this powder. Making the model printed only in shell makes it a lot lighter than a model with sintered completely. So there's a lot difference in density. Also, the model will be a bit less tough, so we can adjust for the toughness we want. The printing time, because we are not sintering the entire surface of the cross section, will be decreased. And also, because the powder collapses when being sintered, we don't need as much material powder for this model. And the second one I would like to show you today is the skeletons. This is somewhat unique to Sinterit. Let's start with some background of this model. Basically, on the picture, you can see this is the same model but printed with different settings. One is with this very fine string-like details, but the other is printed completely without them. Basically, what we are approaching here are the details so small that you cannot normally print them. They are beyond the resolution of the printer. In most of cases, you don't have much control over how much of this very tiny, very fine details will be printed. You either will get them oversized or not printed at all. We give you access to this to the settings. You can adjust how much would you like to print. If you would like to reinforce this very tiny details, or would you like to, if you would like, you can skip them altogether. This would give you a lot of flexibility and allow you to get this very fine details in the way you would like to see. And now one bonus feature of Sinterit Studio. This is not really an open parameter because this is a setting available to everyone. But this is somewhat unique in this technology, namely the layer height. So you can adjust the layer height used for the entire build. Here you can see we use 0.2 millimeter layer height, and as you can see, some parts of the models are quite jagged and not very smooth, but we decrease the printing time. When we go with the finer layers, here we have 0.075, and these are much finer layers, and as you can see, the model is as well much smoother, and all the writings are easier to see. And the final part is the pack density optimization. As I mentioned before, we are trying to utilize the printing volume in its entirety to get these alterations running and to get as much iterations as we can. In this example, we start with a drill housing. This is a quite big model, but adding another one next to it doesn't really change the time and the amount of powder we need for the printing, and even decreases the amount of powder we need for the refreshing. So we can optimize the pack density of the entire volume to get these models basically at two at the price of one. At final stage of optimization, we even utilize the area around our prototypes with the smaller models that will fill in this space. And again, we don't increase the pack density, don't increase the time of the printings too much, and also we don't increase the powder needed for the printing by a big amount, and we are getting very nice results with very low cost of the printing. And here are more examples. For example, we have a big part. This is an air filter housing in our build volume, but adding these smaller parts, water pump body and water pump cover, won't really increase both printing time and amount of powder we need. So the printing costs stay the same, and we can iterate other models as well. Here is very similar case, but we are going with four exactly, well, not exactly the same, but similar models, because these are four alterations with a different angle of attack of the blades of this spindle. And we can make these four alterations with very quickly and very cost effectively. Okay, this is basically it for the presentation part of our today's webinar. But if you have a question regarding specifically your models, or you would like to see, for example, a simulation, or you would like to ask about your application, don't hesitate to contact us. Just leave us an email at contact@sinterit.com.
So thanks a lot, Kuba. Lots of interesting details. Thank you very much. We still have 10 minutes for the questions, and I see there are already some questions. So let me begin. Yes, Anna is already presenting us. Can we alter single parameters, for example, shell, of the given profiles for sinterit powders to just adjust certain properties of the printed objects without starting with the parameters from zero?
Yeah, of course, this is one of the features. You can use our profiles basically two ways, starting with adjustment for our materials. So, for example, you would like to modify one of the materials and save it. You can start with the, for example, PA12 smooth or PA11 carbon fiber, and adjust one of the settings and save it as your own profile. Also, if you would like to develop your own material, which is another type of PA12 or another type of PA11, you can use the profiles we came up with as your guidelines, basically. So there's a lot of flexibility here.
Thanks for your question, Niklas, by the way. I see. Yes. I've already knew that Sinterit is currently working on a development of a low-cost material for Lisa printers. Is there any progress? Yes, there is progress. We are working on this material still, but it's not going to be ready this year. So this is a short answer. Longer answer is that we keep working on other materials as well. And if you follow us carefully for the next days, you will get to know some more information, and there will be some nice surprise on Formnext show in 2 weeks. So actually, exactly in 2 weeks on Thursday, we will be there standing on the booth right now, meeting with you. And by the way, I can take this occasion to invite you all. If you didn't plan yet, please come and see us and find out about our printers there and about our materials and also about the new one there. Kuba, I think this is a good one for you.
You mentioned that parameters affect porosity. The default parameters for the Sinterit materials are compromise between porosity and printing time, or are this best surface quality possible? Basically, you cannot really decrease the porosity of the materials in our offer by altering the models. But if you want to increase it, you can affect the open parameters to increase the porosity. So basically, because we try to achieve the best both surface quality and toughness of the models printed in every material, it's hard to say if there is a compromise. Basically, there is no compromise between surface quality and porosity, because we are aiming for the densest parts we can, because they give us the most toughness. At the same time, we try to adjust the parameters to get the perfect quality. The good example of this is the PA12 Smooth. Actually, the powder has great surface finish, and as well is quite dense, so it's very nicely sintered inside.
Yes, a question from Andrei. Can I get free access to open parameters as a university student? Yes and no. Actually, getting the full access to the open parameters requires having Sinterit Studio Advanced, so the higher version of the Sinterit Studio. With this software version, you have full access. And the good news is that usually most of the clients who are deciding to order our solutions, Sinterit Lisa X or Lisa Pro or even a small Lisa, those clients who are choosing Lisa Pro or Lisa X, usually they are buying a full set with all the equipment that I was showing behind me. So the powder handling station, sandblaster, etc., because you will need it. And if you are ordering a full set, you get Sinterit Studio Advanced in this set already with a very, very discounted price overall. So it's possible to get it easily, and most of the clients get it by default because they are choosing the whole set. Anyway, there is also a special educational offer regarding the Sinterit Studio Advanced. Our distributors can let you know more, or you can contact us directly to ask about this offer as well. Yes, we have a question from Andrea. This is not much a question and more of a suggestion. In Sinterit Studio, you should be able to see how much powder is spent on the models and the printing cost. You could work it out by the already given values, but it would be more convenient to have it there by default. Thank you very much. That's a very, very good remark, because yes, you are right. We have access to the values, and actually we have this in our plan to upgrade Sinterit Studio with this calculator, so to say. This is one thing. The second thing is that I was always surprised, because I'm working in the sales department, so I'm not in this engineering part, and I always was hearing this question like, yeah, how can we get a very simple calculator for the printing costs? Because it appeared to be very, very simple. In reality, it comes out that it's quite complex and quite difficult to give a very, very precise printing cost, especially when you are considering also the energy costs, changing materials from time to time from one to another, etc. But Jakub is dealing with these preparations, especially when he's preparing the simulations of printing. So if you have, not only you, but I mean generally now, if you have questions about the cost, the printing cost, you can simply contact Jakub, contact us on samples@sinterit.com, for example, or upeng@sinterit.com. Send us your models, and we will prepare you a simulation where you will clearly see what is the cost of printing constantly when you keep printing, keep refreshing the powder, printing your elements in the setting that you asked us about. So it is possible to calculate it. We will include it in the future in the Sinterit Studio. That's our plan. And I think we have a last question from Asil. I'm joining from Turkey. Our country is in a deep economic crisis, as you may know. 1 euro is 18 Turkish liras. I have to find a cheaper way, or I will not be able to sell my products at the right price with that cost. Yes, this is a big issue, especially in countries which are dealing with huge levels of inflation. We know it here in the European Union as well, but I'm in contact with Turkey, so I know what is going on there. I think we have to wait for the economical situation to stabilize a little bit more, because it's not only a matter of getting a cheaper powder currently, because with this level of inflation, it will not be possible simply to do a very predictable business. However, we are looking very optimistically to the future. So I believe it's gonna improve. But like I said, answering your previous question about the powder price and so on, we see a need for lowering the costs, because we get these questions as well, the lowering costs of the printing. And like I said, we are working on such material, but we need a little bit more time, because currently we keep developing the powders for Lisa X to get the line, all the full line of materials that we have already translated into Lisa X language as fast as possible. I think we are done with the questions. If you have any more, please write, because we still have 1 more minute. But I think everything was answered and everything was said. Oh, there is 1 more comment. Thank you, Andrea. Thanks a lot. We're glad to hear that this was informative and yeah, and a nicely spent time. At least for us, it was a very nicely spent time, and we are glad that we could share this part of knowledge that we have about the open parameters. Of course, we are open to let you know more. So if you have questions, if you would like to pay us a visit in Krakow and see this equipment live in the room in which I'm sitting right now, it is possible. If you are planning to go to Formnext this year, so to Frankfurt in 2 weeks from now, we will be standing on the booth at that time. Still, it's going to be late already. We will be very tired, but the date will be super super worth remembering, as it always is in Formnext. If you only have possibility, please come and visit us there. You will have a chance of seeing all of our machines there, all of the equipment, asking us the questions live, seeing all the samples live. And if you don't have a Formnext ticket yet, you can get this ticket from our website. You can just visit us on Sinterit.com, and in the left top corner there is a place to click to get the Formnext ticket for free and get a chance of meeting us and discussing with us live in Frankfurt. Thank you very much once again, and hope to see you in the next webinars and to see you in Frankfurt. Have a great evening. Bye-bye.
Take care.